this question of could we get rid of addition or multiplication is completely natural, as long as you're willing to enter a restricted mathematical universe where only a single operation exists, and if you like, you could redefine it to be, a little bit different from the way it's usually understood, as long as it satisfies some interesting laws. You can get down and play with it and see what it does for you. And more often than not, if you set things up correctly in this little restricted world, it turns out describing the behavior of something else in the universe that's interesting and sometimes new. So this is somehow a natural part of the abstraction of mathematics. A second example where multiplication might not mean what you think it means. Multiplication is supposed to take two numbers and give you a number, right? Well, it doesn't have to. If I think about my numbers as being the four positions of my board that all look the same. So can you see my arrow? If I turn my board upside down, the arrow points down. If I turn it around, there's an X on the back. And if I turn it up like this, the X is on the top. So those four positions are all different because I mark them, but in a sense they're all the same because if I rub the marks off, you won't be able to tell the difference. So I can let my four positions take the place of my numbers, and I'll let these motions take the place of multiplication. So that's to say, the act of moving the X from the bottom to the top, or the bottom to the back in two different ways gives me four different so-called numbers. And I could do two of them in a row. I can move the front here to the back and do it a second time. And I'll just pretend I multiplied those two positions, and it gives me some answer. In this case, it would be the arrow pointing downward. And so, again, this behaves something like multiplication in that if you write down products of three things, you could do the first two and then the third one, or you could do the last two and then the first one, and those would always give you the same answer. There's something like the number 1. If you multiply by 1, you get whatever you had before. Well, my number 1 will just be to hold the board in position and do nothing. So if I do that and then something else, I'll just get something else. So these symmetries of an object behave in a way exactly like multiplication. So mathematicians would abstract the basic properties of multiplication and consider them in new contexts. So if I were asked if I would get rid of addition or multiplication, one or the other, on the grounds that there were too many operations, I think I'd have to sidestep the question and just say that a mathematician can redefine addition and multiplication to mean something else completely. So one example where this comes up is in the field of so-called tropical geometry, where one starts with the idea of forming polynomials by adding up products of things. So you take x times y and you add y times z squared, and so that's a polynomial. Well, if you reinterpret your operations to let addition stop being ordinary addition and become minimum, the new sum of two things will be the minimum of those two things. So if I write 5 plus 3, then I'll get the minimum, which is 3. And I'm going to redefine multiplication to be ordinary addition. So I'm going to say 5 times 3 in the new sense is actually equal to 8. Expressions, it turns out, in the new plus and the new times satisfy some rules which are much like ordinary arithmetic. So, you could make sense of something like this here. Distributivity of addition or multiplication over addition. Well, there's no reason why that should work if I just made up any old definitions of addition and multiplication. But it turns out in this case, 7. That's supposed to be the minimum of 8 and 7. And you'll find if you do it the other way over here, you get a 2 here, and 5, that means ordinary addition. 5 plus 2 is equal to 7. So this kind of thing actually turns out to be useful for finding approximate solutions to polynomial equations and converting some kind of more complicated construction into this funny game with the minimum and plus instead of addition and multiplication. And so by changing the way in which we understand these two operations, we can actually accomplish something new and useful.